Hi, hello everyone. Thank you for coming back to the last part, the last installment of the Python for OR, where we will have Gabriel Humphrey talking to us about how and why we should use Pandas. So without further ado, Gabriel, the floor is yours.
Thank you. Hello everyone, good afternoon, or day or night. Let me share my screen with you. Okay, so welcome everyone to this Pandas for Operations Research seminar. So far in this workshop series, you have been able to understand the basics of Python and also to write some basic models with Cplex and Gurobi. So after that, you should have some computational experiments on some model that you want to develop. And the next step is to analyze the results of these computational experiments. So that's what this presentation is about. So let's have a quick overview on a very optimistic research workflow for OR. Usually we come up with some research idea, and then we try to propose some model or algorithm, like a decomposition algorithm, to solve this research idea, this research problem. And then we'll start to code our model or algorithm, and then back and forth we are going to write code, fix bugs, and so on, until we have something ready to run our computational experiments. And well, after that, we have computational results, and we have to analyze these results, and we have to discuss the results in our paper. And pay attention that there's a asterisk here that shows that if this goes wrong, you may have a huge problem when publishing your paper, because if your results are not well discussed or not well analyzed, then they may not be convincing enough to warrant a good publication. So the goal of this presentation is to introduce you to Pandas, Python data analysis library, and to give you a set of tools that you can use to present your computational results. So a word about spreadsheets. I use Excel to analyze my data. I used Excel in the past, and they have some shortcomings.
I'm not sure, but I believe that, Gabriel, you might be having
Hello?
issues with the internet.
Hello?
The connection.
Hello?
Can you hear us, Gabriel?
You hear me? Yeah, I do.
Okay, now you're back. I think you have to restart.
Yeah, did you get the spreadsheet slide?
Yes.
Okay, so I have used Excel spreadsheets in the past to analyze my data, but they have some shortcomings. For example, the logic and the presentation of Excel spreadsheets is all mixed. This means that you have your data that you paste on Excel, and then you analyze this data with some formulas, and then you present this data, and everything is mixed in the same worksheet. So you don't know very well what's going on. And it's very hard to check if what you did is correct. So it's very hard to find bugs, and it's very hard to modify your workflow without introducing any bugs. So let's say that you want to make a new analysis, and you may break what you already did. If I open my spreadsheets for my first paper in the master, I have no idea what I did. Like, if I want to extend my project, I'll probably introduce some bug in the spreadsheet. So that's a limitation of spreadsheet, and Pandas doesn't have its limitation because you're writing Python code. So it's much easier to audit your Python code. But I'm not against spreadsheets. They are a very useful tool, and they are not mutually exclusive with Pandas. In fact, you can read and write from and to spreadsheets with Pandas. And myself, I often export my final results to an Excel spreadsheet after processing my data with Pandas, because I find it much nicer to see my results on a spreadsheet form. And I can play a little bit more if I want to do some quick analysis. So don't stop using Excel. Pandas is just an additional tool to make your data processing pipeline more automated and nicer and less prone to bugs. So I'll just show how my data processing pipeline is typically. So I run experiments, and for each experiment, I have a line with my results, and I'll save all these lines in a CSV file, a comma-separated value file. And then I will open the CSV file with Pandas. Then I will process it somehow. I will calculate the gap, show the execution time, etc. And then after processing, I will generate some report, which can be an Excel file, LaTeX tables, graphs plotted, etc. So that's the pipeline. And the important part is that the data processing is all automated with Pandas. So let's set up Pandas. I think most of you are able to install Pandas already from our email, but if you didn't, you can install Pandas simply by running pip install pandas or conda install pandas. It's a bit easier than installing Cflexible Ruby, but you may have some errors. So if you have some errors, I can refer you to this link on the Pandas documentation on how to install it. But yeah, after installing, you can import Pandas by simply writing import Pandas. It's common to use the abbreviation PD for Pandas, so we import Pandas as PD. So we write PD instead of Pandas, it's much shorter. And if you want to check, for example, if it works, you can print the Pandas version with PD __version __. And if you install Pandas recently, probably you have a version a bit similar to mine, 1.0.3. So you have Pandas working, this is all you need to do. So Pandas, the central part of Pandas is the data frame. It's the main data structure of Pandas. When you read data into Pandas, you will have a data structure, a data frame. And the data frame is basically an Excel sheet. It's very similar to an Excel sheet. It has columns and it has rows. It has names for each column. So most of the time, you're going to be working with a Pandas data frame. This picture is from the Pandas official documentation website. So how to create a simple data frame in Pandas? We can pass a Python dictionary. We can build a Python dictionary and pass it to Pandas such that it creates a data frame like this one. It's a table after all. So how do we create a table like this? Well, we create a dictionary called data with two keys. The keys are the columns of my data frame. So I have col1 and col2, which correspond to this column here. And for each key, we pass a list of values with the values for each column. So A, B, and 3, 4. So I call PD point data frame, I pass my dictionary, and it will create my data frame, which I will save in a variable called simple. And if I print this variable on Jupyter Notebook, it will show me the table here. So if you have any Python program where you want to pass data to Pandas, you can create a dictionary with your program and simply pass the data to Pandas. And by then you will have the full power of Pandas to analyze your data. And here are some examples of basic data frame operations that you can do. The simplest one is to check the dimensions of your data frame with PointShape. So I write simple PointShape here, and it returns me a tuple with the values 2 and 2. It means that I have 2 lines and 2 columns. I can access a specific column of my data frame. If I write simple square brackets col1, it will return me the values of the column col1. I can also create a new column. So if I write simple col3 and I pass to it a list of values, for example, some values, and I print my data frame, I will have the 3rd column here. And of course, I can delete a column. So if I write del space simple col3 and print my data frame again, you'll see that col3 is gone. So you can edit this data structure as you could edit any other data structure. And of course, you can iterate over this data structure. So let's say that I want to iterate over each row of this data structure. I can use the function iterRows here. And this function gives me a pair of index and the row values for each row of my data frame. So if I print the index and the row, on the first iteration, I will be in the index 0 here. And this is the row that I'm printing. So for this row, the value at col1 is A. And for this row, the value at col2 is 3. And then I'm on the second iteration and my index is 1. And I have different values for my row. So you can iterate over your data frame like this, and you can assign new values to your data frame, transform it, do everything here. Now, the data frame is the main data structure of Pandas, but it is composed of columns, and your columns have the real data. And in fact, each column is what Pandas calls a series data structure. So a series is basically a data structure that has a name, that the column name, the data type, some index, and the data itself. So when I access simple square brackets col1, this is actually a series. And the name of this series is col1. The data type is object. Its values are A and B. And the index is 0, 1. So if you call the function type on this series, you'll see that it is in fact a Pandas series. And the same way we can create a data frame from a Python object, we can create a series from a Python list. So if I pass a list of values A, B, C, D, and I call PD point series, this will create me a series A, B, C, D. Why am I'm telling you this? Because if you want to do some statistical functions on your data inside your Python program, you can easily pass a Python object to Pandas, and then you let Pandas take care of the work for you. You don't have to re-implement important functions. So you saw here that the index of a series is automatically a numeric series here from 0 to 3, but we can specify different indexes. So let's say that I have a series with the population of provinces and territories of Canada, and I can create a series indexed by the 2-letter abbreviation of each province and territory if I pass a dictionary, where the keys are the index and the values are the population for each region. So I pass population data to PD point series, and I'll have this population series here. And if I print a population series, you'll see that the index now is a string and the value is the population. And of course, we can access a row of this series by the index. So if you want to know the population of Quebec, we write population QC, and we have about 8.5 million. And you can also give a list of indices to access the population of multiple provinces and territories. So I pass a list with QC and ON, and this will return me a subseries of my population series with the populations of Quebec and Ontario. So this year, the first block returns an integer, the second block returns a series. We can also visualize a series, and that's where Pandas starts to get very interesting. Once you have data in data frame format or a series format, we can easily run we can call functions that can plot, can do summary statistics. We can very easily understand visually how our data works. So we can call the series point plot function to plot a series, and below we have a bar plot of our population. So I call population point plot kind equals bar, and you see that the x-axis automatically has my 2-letter abbreviation because this is the index of the column, and the y-axis has the population of each province and territory. So you can see very easily and with minimal effort how our data looks like. We can also do very simple mathematical operations on series, for example, summing a value to it, subtracting, multiplying, dividing. So let's say that we want to put the populations all relative to the province with the biggest population. So we can create a new series, population relative, which is equal to population divided by population point max. So population point max will return me the biggest value of the series, which will be the population of Ontario. And I'm dividing each element of the series by this number. So if I print population relative here, you'll see now that all populations are relative to Ontario's population, which is 1 now. So you can do all sorts of mathematical operations to your series. A common mathematical operation that I do in my series, well, I have a CPU time column sometimes, and I want to convert between minutes and seconds, for example. Something else that you can do with series is to filter them. So maybe you want to show results only for a certain kind of algorithm or for a certain kind of instance. That's when you filter your data. And to filter data in Pandas, you use the conventional Boolean operators that you have in Python, like less, bigger, equal, less than or equal. And when you use those Boolean operations on series, this will return you a list of Booleans that will tell you if each row satisfies the criteria of your Boolean operator or not. And you can use this list of Booleans to filter your series. So if I write population greater than 8 million, you have a new series here with Boolean values, false, 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 and you see that only Quebec and Ontario will have true because they're the only provinces bigger with population bigger than 8 million. So if I get this Boolean series here and I pass under square brackets to my population series, this will return me only the rows of the series that where this condition here is true. So it will return me Quebec and Ontario again. You can try by yourself just passing a list of Booleans, like you open square brackets and you write true, true, false, false, false. You will see that it will return only the values that are true. So that's how you filter in Pandas. You can write very complex Boolean expressions here. Okay, so now you know how to install Pandas and you know how to create a basic data frame. But what's really interesting for us is when you have computational results in a CSV file and we want to read them into our data frame. And then do some processing and of course, writing to some file type. So Pandas can read and write from into many different formats. For example, it can read from CSV and TSV files, Excel files, JSON files, Stata files, SQL tables, HTML tables, and much more. If you want to know more about the formats that Pandas supports, you can go to this link here. So every time you read from a file, it will generate a Pandas data frame to you. And when you export your Pandas data frame, it will be exported to any of these file types here. So let's read a CSV file, for example. Let's read the famous iris flower dataset. This dataset has the measurement of different species of the iris flower, and we can use the read CSV function for that. So here I have a link to a website that has the CSV of the iris dataset, and I can pass this link to pd.readcsv. So not only I can open files on my local computer, but I can pass links to the internet. So this is going to read the iris dataset CSV file. And if I print iris point head, this will show me the first lines of this dataset. So you can see that this dataset has 5 columns. The first 4 columns are measurements of different flowers for their sepal and petal length and width. And the 5th column is the species that the species of the flower that was measured. And so we read a CSV and it generated a data frame for us. And it can write the data frame to some format. And the format that I very often write to is latex. We can export our data frame directly to a latex table. And this is very useful because editing with latex tables by hand is very hard. And I always make mistakes. I don't want to do this manually, so that's why I find Pandas so nice. It can automatically generate LaTeX tables for me. So if I have a data frame, I can call the toLaTeX function, and it will simply generate me the LaTeX code of my table. So here I call my simple data frame again, and I call the point_toLaTeX function, and it will return me the LaTeX code of this table that I save on a variable. And if I print this variable, you see the code here with begin tabular, and it's already a bit formatted. So this is very useful. I use all the time. Sometimes I don't copy the whole code. I just copy the data lines here because I have my own formatting for LaTeX tables. But I always use this all the time because there's no way to make a mistake if you do this. And you can write to other interesting formats, for example, Markdown. Markdown is a plain text markup language. In fact, the text you're seeing here was all generated from Markdown, including this table here. So when you want to write nicely formatted text on Jupyter Notebook, you are using Markdown. And we can ask Pandas, for example, to generate us the Markdown code of a data frame. So this table here was generated from this Markdown code here. So if you call simple point to Markdown, it will generate us this code here. Okay, you already know how to read and write data. So what's missing is how to understand your data, how to analyze it and draw conclusions or do some transformations on your data. And that's the most interesting part because that's where you're going to extract value from your data and to draw nice conclusions that will help you make tell a good story about your research proposal. So the first step that you can take to understand your data is to ask Pandas to give you some descriptive statistics on your data frame. And you can easily generate the statistics using the describe function that Pandas gives to you. So if you simply write iris point describe, Pandas will generate summary statistics for all numeric columns of your data frame. So for example, you have the mean value of each column, standard deviation, etc. So this can give you a very quick overview of what your data looks like. Of course, if you want to call this function independently on each column, you can do them. So for example, we could call iris point sepal length, and this is a series now. We are in a column, so this is a series. Point mean, so I'm getting the mean of the sepal length column. It's standard deviation with point std function. It's minimum value. It's quantile. We can specify which quantile we want, and its maximum value. So you can quickly use these functions independently if you need some specific information about a column. Now, if your data represents a time series, Pandas also has some very interesting functions. So let's say that we have a series, for example, with daily COVID cases. It's very common to look at the 7-day moving average of cases to identify if we have a trend going up or down in the case number. And Pandas lets you calculate this very easily. So let's generate some random series here from a Gaussian distribution with mean 5 and standard deviation 1. So I generate 100 points here, and I pass this dictionary to a data frame. So I created a data frame now with my time series, and I create a new column called rolling average. And to calculate the rolling average, I call df point rolling. Then I specify the amount of periods that I want, and then I specify the average function. I could have the rolling average, the rolling standard deviation, the rolling maximum. In this case, I specify the mean here. So if I print the last rows of this data frame, I will have my series value here and the rolling average of this series. Now it doesn't, well, it doesn't help much to have this information here, but we can plot these columns. So if I simply call the f.plot, it will plot me both columns. So the blue line is the series itself, and the orange line is the rolling average line itself. So it can easily show me if there's some trend over time in the series. Okay, so another interesting function that you can use to understand your data is the value counts. So back to the iris data set, we have measurements for different types of flowers. In fact, we have 3 different species of iris flowers that were measured. And we want, for example, to understand how many flowers of each type were measured. So we can call the value count function on the species column to count how many times each category of flower was measured. So if I call iris point species point value counts, it will tell me that 50 flowers with species equal versicolor were measured, 50 of species setosa, and 50 of species virginica. So it's a balanced data set. We have 50 measurements for each species of flower. Another interesting function that Pandas gives to you is the hist function. So it helps you to plot an histogram of a series. And with this, you can quickly check the distribution of any of your columns. So I call iris point sepal length point is here. So you can see that more or less the average of the sepal length is between 5.5 and 6. And there are some outlier here. And an even more interesting function is the scatter matrix function that lets you plot for each pair of attributes of your data frame, it generates a scatter plot for you. So this is very useful when you have new data and you still don't know where to analyze or where to look at. You don't know what the patterns are, so you want to look at everything. So for each pair of columns, I want to know how they relate to each other. And based on that, maybe I will look further into a specific pair or not. So if I call PD point plotting point scatter matrix, and I pass my iris data set, it will generate this matrix of scatter plots. And for example, if I go to sepal length and petal length, we are in this scatter plot here. And we can clearly see that there are 2 different groups of flowers. So if we had a clustering algorithm, this algorithm will probably generate 2 clusters here. Whereas if you looked at the sepal length and the sepal width, we will be in this scatter plot and maybe it will have a harder time splitting clusters correctly. And the diagonal of this scatter matrix is simply the histogram of each attribute. So this first histogram here is the same histogram from the previous slide. So this function is very useful. It will quickly give you a visual insight of how your data behaves. You can also generate box plots. Box plots are very common in OR paper. They can be used to visually show that one algorithm has a better performance of the other. So let's say that we have 3 algorithms, algo 1, 2, and 3. And I randomly generate their performance here from Gaussian distributions. And I pass this data to a data frame. So my data frame looks like this. I have 3 columns, algo 1, 2, and 3. And each row has the performance that this algorithm had on this row. So I could, for example, just show the mean values of each algorithm, but I will have very limited information on its performance. I will have only its mean performance. I don't know how, for example, is the distribution of the performance of each algorithm. So that's where a box plot is important. So if I simply call df point box plot, it will generate me a box plot for each column. So I have algo 1 here, algo 2 here, and algo 3 here. And you can clearly see that algo 1 is the worst one, then algo 2 is in the middle, and algo 3 is the best performing one. So instead of just showing numbers or the average performance of each algorithm, Pandas lets you quickly generate these nice plots, which may sound way more convincing when you're trying to sell your story in your paper. Now, a last thing I want to talk is data aggregation in Pandas. So Pandas has this function called group by, and group by is a function that will that will get a data frame, and it will group the rows of this data frame based on an attribute. And then for each group, you can pass it through an aggregator function, for example, mean. So I can group, for example, in our iris data set, I can group my rows by species. So I'll have 3 groups, one for each kind of species. And I can call the mean functions such that I have mean information for each group. So here I called iris point group by species point mean, and I have a new data frame that is returned by this function. And the index of this data frame is the species of the flower. And the columns now show the mean values for each group. For our OR applications, this may be, well, we can group by algorithm type, we can group by some special search strategy that we use in our algorithm. You usually use the group by function when you want to highlight the effect of some characteristic that changed in your computational result. And we don't only have to group by with just one aggregator. Maybe I want to show the mean values of my groups and the standard deviation of my group to see if their distribution overall is better than the other groups. So I can call iris point group by, specify my attribute, then call the ag function for aggregate, and then I pass a list of aggregators. So I pass mean and standard deviation. So now I have the same groups here, but I have mean and standard deviation information for each group and each column. And this is also very common in OR applications. Maybe I want to show the mean gap and the standard deviation of the gap. So Pandas lets specifying aggregators, dealing with your formulas. At each step of this workflow, you can introduce bugs, and you may be not sure that you did everything correctly. Okay, that's all I wanted to show today. Here are further links for reading. I find these resources very useful, and they helped me make this presentation too. So there's the Pandas official documentation, of course. I want to give a warning about the Pandas official documentation. When I started to learn Pandas, I felt a bit frustrated because sometimes the examples that they give, they don't speak very well to me. But over time, I understood that Pandas is used by all kinds of professionals. So not all time I'll have an example that is specifically tailored for people that work in OR. So keep this in mind. You may feel a bit lost when reading some examples, and you may feel a bit frustrated that you will not find exactly what you need sometimes. But it's because Pandas is a really flexible tool, and all kinds of professionals are using this to analyze data from all different kinds of fields. You can always ask questions on Stack Overflow. Usually when I ask, in 10 or 20 minutes, somebody gives me the answer. They are very helpful. There's also this 10 minutes to Pandas guide in the official Pandas website. There's this Kaggle Pandas micro course. I did it and it's very nice. It really helped me understand better Pandas. And there's this exploratory data analysis with Pandas, also on Kaggle. I recommend you to check all these links. I also recommend you to have a better look on these libraries that are very related to Pandas. So NumPy for scientific, for numerical computation, Matplotlib and Seaborn for plotting. You saw today that Pandas allows you to plot things very easily, but Pandas is not a plot library by itself, it's a data analysis library. So the plot functions that Pandas has, they are not that flexible, and sometimes they are not the most beautiful kind of plot. So if you invest some time in learning Matplotlib and Seaborn, you will have way more flexibility in which kinds of plot to generate or how to customize your plot to make it look better. And another library that is worth checking is SciPy. SciPy is a scientific Python library, and it has all kinds of stuff ranging from LP optimization problem solvers to numerical derivation and integration. There's a lot of stuff in SciPy, and it's a very interesting library. Okay, so now it's your turn to do some simple exercises to practice what you learned today. So we have 4 exercises, and I'll quickly go through them now. So the first exercise, you will generate a data frame with 2 columns. The first column will have the values from 1 to 10, and the second columns will have these values squared. And you have to plot this. So these numbers, but these numbers will be generated from a Gaussian distribution, and it will have mean 10 and standard deviation 5. So after generating these values and creating a series with these values, I want you to run some summary statistics on the series to check if the mean and standard deviation are close to 10 and 5. And you can use these 2 functions here to accomplish this task: random point Gauss and describe. The third exercise, you will load the iris data set from the internet. It's a filtering exercise. So you will load this data set, then you will filter and keep only the rows that have the Setosa species. Then you'll keep only the rows with sepal length between 4.8 and 5.2. And in the end, I want you to show the number of rows with this data frame using the PointShape. And if you do everything correctly, you should have 28 rows. And the fourth exercise, which perhaps is the most related to us in OR, you have the performance of 3 different algorithms, A, B, and C. So their objective is 100, 105, and 110. And you know that the optimal solution for whatever instance they are trying to solve is 100. So the goal here is to create 2 additional columns, is optimal and gap. So the is optimal column will have the value true if your algorithm has the optimal objective and false otherwise. And the column gap will have the optimality gap to the optimal objective, which is 100. And you can use this formula here to calculate the gap. Okay, I let you do the exercise now, and we will be available to answer questions. As we don't have lots of people today, maybe we won't create the break rooms, and we'll stay here to do a question and answer session if you have any further questions. Well, thank you for your attention.
Thank you, Gabriel, for your presentation.